In this linear interpretation question, we're given an equation that models a situation, right? It gives us the total cost C to produce a quantity of X units. And we're told that the quantity of units produced increases by 39. What is the corresponding increase in the total cost? So you could plug in 39. Wouldn't seem like a bad idea. And there is a way to do that and to make it work. But you have to be very careful with how you do this, because if you plug in X is 39 and you calculate what this is going to be, so it'll be 39 times 5/4 plus 406, you'll get an answer, which I guess you could, do we have enough room to bubble that in? I guess or fill it in. I guess we'd have to round. But point is, you get something, but is this really the answer? Because notice the question saying, it's not saying what is the cost of producing 39 units. It's if the number of units increases by 39. What is the increase in the cost? So whenever we see a problem talking about a change in one value compared to a change in the other, we should be thinking about the slope. We should be thinking about the rate of change. So I'm going to show you the way that I prefer doing this one, and then I'll also show you how you could do plugging in 39 and still have it work. But let's do the way that I like, which is to really focus on the slope. So we know normally the slope is defined as the change in y is the change in x. Now in this case, we have to make a sub in. Instead of y, we have c. So I'm just going to rewrite this as the change in c over the change in x. And we know in this case, the ratio of the change in x to the change in c, or the change in c to the change in x, is 5:4, right? For every, and we can, some questions, they might even want you just to interpret what the slope means. And so one interpretation would be, as the quantity x increases by 4, the cost c increases by $5, right? That's the ratio. And so what we're going to do here is we're essentially going to set up a proportion. We're going to say whatever our rate of change is, it's got to fit this 5:4 ratio. So where should my 39 go? Well, that is the increase in the units, which is x. So I'm going to put that on the bottom here, and then I'll just call this c on the top, right? Because that's what I want to find. And I have now a proportion using my slope to help me find c. So let's go ahead and cross multiply. 4c is equal to 39 times 5, which I guess is, what is that, 195? But let me just check it in the calculator. Yep, 195. And that will divide both sides by 4. Now you could just do 195 over 4, and that would be fine. But I think we can just calculate what that would be. It's also 48.75. So I think either of those, you definitely can fit these as answers into the box. So you should be good with either of these answers. So that's the way I prefer. I like to focus on the slope, sort of focus on the slope definition and set up a proportion. So now, as promised, let's look at the other way to solve this, where we can plug the 39 in. We just have to be careful to make sure we're finding the increase in the cost, not just plug in x is 39, find the cost. We want the increase. So what we're going to do first, before we plug in the 39, is we're going to plug in an initial x, so that when we plug in 39, we're comparing an increase in the x of 39. You actually could use any two numbers for these two test points of x, as long as there's a difference of 39. But just to make things simple, I'm just going to use 0. So what is the cost for 0 units? Then we'll find the cost for 39 units, and then we'll subtract those costs to find that increase. So when x is 0, that term just drops out. And so we're going to find that the cost would be 406. And so now this, I forget what we had plugged in. I forget what we got when we plugged in last time, but we'll just do it again. So we're going to plug this in for x and then compute this. And I think it was 454.75, but let's see, 5 divided by 4 times 39 plus 406 is 454.75. And now we can just subtract the two costs to find the difference. And again, we get 48.75. Now, if you'll notice, when I was doing the calculation, when I did the 5 over 4 times 39, we actually got the answer directly, 48.75. And then I added the 406, and then we ended up subtracting the 406 off. So as a shortcut, you might recognize, look, as x goes up by 39, this is the quantity in the equation that will contribute to the change in the cost, right? This, as the initial value, or the y-intercept, is constant, right? It doesn't change as x changes. So we can almost ignore it, and that's why when we plug 39 in for x, if you actually just do 5/4 times 39, you also get the answer. So any of these methods is totally fine. Like I said, I like the first. I think it's the most robust. I think it gives you the most firm grounding in the definition of the slope and how to use it. But plugging in, as always, can be a nice, at very least, backup method. And either way, you should get 48.75.